Analysis we'll be seeing with the help of your, okay, you got it, it should be sine wave or cos sine wave. But how we'll understand the oscillation part in SHM? For that, we'll be taking first your the sine curve. Say I'm taking here the sine curve. Sine curve means it will start from origin. So it will go up and then half cycle here. Then it will have another cycle, same amplitude downward, means same maximum displacement. And then it is coming back and the things is repeating, right? So this side is your displacement. Y, I can say this is your displacement, right? And this side I can say theta, that is your omega t. T is the time, omega is a multiplier. You can understand this. Your omega is the angle by time, correct? Linear part, it is distance by time. Here it is, distance is nothing but the angle, time is time. So that's why we can write theta is equal to omega t. So basically it will give the angle. Now we know one cycle is completed in the angle 2 pi. Half cycle, it is your pi. Even half of that, if I take it, this will be your pi by 2. Probably this, then if I am taking 3 pi by 2, right? So these are the angles at which the displacement of the particle can be understood easily with the help of line diagram. What is that? I'll just draw the line here parallel to the y-axis, right? And try to understand the displacement of the particle. Means what is happening, that body or particle is, first the displacement is increasing with the time. If the time increases here, displacement increases. It is happening till it reaches the maximum, right? It reaches the maximum. So any point in between P I can take. Once it is reaching to the maximum, say it is A, and then in between somewhere I have taken as P. So what I'll do, I'll drop a perpendicular from these points. I'll drop a perpendicular from these points, correct? So now this will be your, from O, if I drop perpendicular here, that is the start point. So here corresponding O will be here, correct, on the line diagram. Now, once the body is reaching at P, here it will reach at P, corresponding point. Once it is reaching at A, corresponding point on the line diagram is A. Now, what is beyond that? Beyond that, the particle, you can see it is just coming down. So if I drop a perpendicular, each and every point, you can just drop a perpendicular on that. I'll find my line diagram, and that will give you how the oscillation is taking place. So it has, you see, it is going to A. Here in the line diagram, it has gone to your A, correct? And then it is coming down. Finally, it is 0 here. The displacement is 0. Once it is coming down, you see, the displacement is coming down. Displacement is nothing but how much it has gone up, right? So that is coming down. Finally, at this point where it is crossing the x-axis, this is 0, right? Here also on the line diagram, it will come down and it will be 0. Beyond that, see, now it is going on negative side. If I draw perpendicular, I'll get all negative. And it is maximum at this point. This point, it is your, say, A dashed. Let us take this is your A dashed. So corresponding point here it will be, if I drop a perpendicular from this point, yes, I'll be getting this as A dash. Now the particle has gone up. So on the line diagram, the graph has gone up in the figure, and then coming down. Then it has crossed while coming down, it has crossed the mean position. This is my mean position. It has crossed it and then going down. And then you see the graph is going up, correct? If the graph is going up, if I drop a perpendicular on this, I find the particle on this graph is going back towards the equilibrium. Here it is reaching to the x-axis where it has reached to the mean position. So one cycle has been completed. It has gone up, came down, and then again gone up. One cycle is completed, and the things is repeating. This is just one cycle, and the things are repeating, correct? So your from here to here, this will be known as one cycle, right? This is the basic, and then this time in which it is completing the one cycle is your capital T, which is known as capital T is your, yes, time period, right?
Mm.
So up to that is clear how what is happening here, right? Your
Yeah.
graph is first going up on this, reaching to the maximum, coming down, it will cross the equilibrium position, then go to the maximum, and then it goes up and reaching here, and the things are repeating, right? This sine curve I can replace on the line diagram. This is the analysis we are doing. Means once the particle is oscillating, it is something like on the line diagram we can understand. Suppose you take a case of say I've taken the tub full of water, and then I put this small cube on that. Cube will float, correct? So once it is floating, that is the normal position. Now you just press it down. Just press it down and leave it. What will happen? Cube is going to oscillate in the vertically along it, right? Same case, if the vertical spring is there, you have just put some mass in at the end, some body at the end, and I'm displacing it slightly down and leaving it. It is going to oscillate, right? It's going to oscillate. If there is no air resistance, no force, viscous force and all in the fluid, you will find that it will keep oscillating between the two extreme and forever, right? Same thing we can have with the sorry, with the pendulum case. Pendulum case, what happens? It is going to just displace it from the normal. Suppose pendulum is there, slightly we displace and leave it. Is going to oscillate between these two extreme. And so all these cases are executing SHM, right? We can have many more other examples. So up to that is clear how we are going to analyze. We can analyze this with the help of a circle model. We call this as circle model. How come? See, same thing. We had taken a line, and side of it, I'll putting circle here now. I'm putting a circle here. So in the circle, the radius of the circle is nothing but it is giving you the radius of the circle is nothing but giving its amplitude, right? That is your maximum displacement on either side. So in this circle, if I extend it, this is your A dash, sorry, this is your A, and extend it, this fellow on this side, I'll be getting this as A dash, right? This is your center of the circle. And if I draw this A to A dash, this will make my line diagram, this line diagram. Now on the circle model we are seeing, means this point will be your O, corresponding O here, right? This is center of the in between we are having point P somewhere, extend it, put on this, correct? So we got a point here. This is your corresponding point is P here. Now C to P I'll join. C to P is radius. C to P is same as C to A, C to A dash. That is your amplitude. Radius is your amplitude. Now the particle is, see, it is moving, it will move like this. Am I right? Is going to move in that direction, anti-clockwise, on a circle. And projection of the particle at any time on the A dash will be giving you the displacement, which has to be, suppose if I have taken here from this point P, I have dropped perpendicular and calling this point M. So C to M is your displacement for the sine wave which is reaching here from O to P. Here it is traveling on a circle from O to P along the anti-clockwise with an angular velocity, constant angular velocity omega, right? These are the things Now, if I see this angle, initial angle is your, at any omega is a fix. At any time t, suppose this fellow has covered a angle of how much? Omega t, right? So here, if I drop here, this is the angle from here to here. This is your how much? Same omega t. This is your omega t. Theta is equal to omega t, right? So if this is omega t, that angle also has to be omega t, correct? This side angle also has to be omega t. Yes or no? Now C to M, this is your displacement at any point P. What is the displacement of the particle? Correct? Mind it, this C to P here, C to M here, sorry, C to M here is same as O to P here, same as here the displacement here. If I drop here, this is the displacement, right? So all are same. Now here, why, if I want to understand what it should be, I'll be taking right angle triangle in your CPM, right? In the right angle triangle CPM. Check it. This is, I am taking right angle triangle. So yes, I can write sine theta, that is sine omega t. I am talking about this angle here. I am talking about this angle here, correct? This one, omega t. So sine omega t will be what? Opposite by hypotenuse. Where is the opposite? Opposite to the angle. So this has to be your CM divided by hypotenuse. This will be your C to P, correct? CP. Yes, so I am able to write sine omega t is equal to Cm is nothing but y, and this Cp is nothing but your amplitude, right? Cp is your, you can check it, Cp can be written as your Ca, right? Cp can be written here as your Ca, and that is nothing but the A, which is your amplitude. So I can write y by A. So see what I am getting, y, the displacement at any time t, right? Where theta is omega t, we are getting y is equal to A sine